Hello, welcome back. We are going to do a quick review of what we learned last week to kind of refresh your memory about the difference between a series and a parallel circuit. And from there, we're going to combine the two and put them together. So quick refresher, a series is one where there's only one way through, there's only one path for the current to flow. Parallel circuit is one in which there are multiple paths. There's more than one way for the circuit to follow, a path for them to follow. So as you guys look at our problem number one, find the current through and the voltage drop for each resistor. As you look at it, first thing you do is find the battery. The short side is negative, the long side is positive. I have them labeled for you. From there, electrons start at the negative and then they move away from the negative and towards the positive. So as I follow the circuit, turn on my pen. The electrons will follow this path, and when they get to right here, they have two options. Some of the electrons are going to go up this direction, and some of them are going to go up and follow the other direction. So some of the electrons are going to follow the pink path, while the other electrons are going to follow the blue path. Okay, this is a parallel circuit because there are multiple paths, pink and blue. Look at colors if it helps you. All right, from there, if you remember from before, because there are multiple paths, when you look at a parallel circuit, you have to find the total resistance, the REQ, you have to do 1 over. So step 1, we're going to find the total resistance. For parallel, we have to do 1 over REQ equals 1 over 75 plus 1 over 170. 1 over 75 plus 1 over 170. So into my calculator, I type 1 divided by 75, I hit enter, plus 1 divided by 170. That gives me a really small decimal, 0.0192. That is not my REQ. That is 1 divided by my REQ. I have to do that quick flip. I have to take 1 divided by the decimal. Your total resistance will never be that tiny decimal. When you see that, you have to remind yourself, I have to do 1 divided by. So when I take 1 divided by 0.0192, I find that the total resistance for this circuit should be 52 ohms. From there, step 2 is always take the total resistance and the voltage of the battery and find the total current that's going to flow through. So delta V equals I times R. The total voltage of this circuit, starting at the beginning, is 50 volts. I'm solving for the total current flowing through, and my total resistance was 52. Okay, so I need to take 50 divided by 52. That's just under 1. I got 0.96 amps for my total current. All right, here's where our two things differ. There's two places for parallel and series. The first one is how you find the total resistance. Because it was parallel, you can't just add it up. You have to do 1 divided by. And the other one is for parallel, the voltage is going to be the same between the two of them, but the current is not. The current splits. Some of it follows pink, some of it follows blue. So the total current, 0.96, that is not the current for either one of those because it splits. Okay, I'm going to get my thing set up. I'm going to find I1 and delta V1 and I2 and delta V2. I always put them in 2 spots. You can kind of pick. I'll have a running tab over here, and then I kind of like to do all my work up on the diagram so I can kind of see where I am at any given time. Okay, for parallel, how you find the voltage and the current. The voltage is a given, and here's why. As you follow any path, let's say I follow the pink path, the total voltage that the electrons leave with, in this case it's 50, all of that voltage has to be used up by the time they get back to the battery. That's just one of the rules of electricity, one of Kirchhoff's laws. Okay, as I follow the pink path, there's only one resistor right here that those electrons flow through. We need to use up the voltage before we get back to the beginning. If there's only one place to put the voltage, then the voltage, if you start with 50 and you have to get rid of 50, it uses up all 50 volts in order to push through that resistor. All right, so delta V1 is going to be 50. It's going to be the same thing for resistor 2. If you follow the blue path, no resistors until we hit right here. There's one resistor, and then we work our way back around. All of the voltage has to get used up in order to push through this resistor. There was a total of 50 volts to start. You have to use it all up to get through the one resistor. All right, so the voltage is the same for your parallel circuits or your parallel resistors. In order to find the current, I'm just going to switch to colors and do the pink one first for resistor 1. So resistor 1, delta V1 equals I1 times R1. Well, I know the voltage is 50. I want to solve for the current through resistor 1, and the resistance is 75. So if I take 50 and divide by 75, I am going to get 0.667. And I'm going to put it right here as well. You can round that to 0.67, however you want to do it along the way. I'm then going to switch to my other color, my blue electrons. Resistor 2 is on the blue path, so delta V2 is equal to I2 times R2. The voltage was 50. I'm solving for the current, and the total resistance was 170. When I take 50 and divide it by 170, I get 0.294. You can round that differently. That's totally fine. Some of you will need to work it out like this to keep track of what you're doing. Others of you will kind of just use the diagram in order to work your way through. It's up to you, whatever way works best. So that's a quick review of a parallel circuit in which the resistors are parallel. That means there's multiple paths through the circuit. It could go the pink way or the blue way. Let's look at the second problem. This is an example of a series circuit. So once again, you find the negative sign, you flow away from the negative toward the positive, and while you do, you notice there's only one path for them to follow. It can't branch off into different places. That is what makes this a series circuit. And along the way, it runs through resistor 1, resistor 2, and resistor 3. Okay, step 1, you need to find the total resistance. In order to find total resistance for a series circuit, all you have to do is add them up. So I need to take 25 plus 150 plus 50, and when I do that, I should get 225 ohms. That is the total resistance for this circuit. Once I know the total resistance along with the voltage of the battery, step 2 is always find the total current. Delta V equals I times R. The voltage of the battery is 20. That is equal to the total current times the total resistance that I just found, which was 225. If I take 20 and divide it by 225, I get 0.089 amps. All right, how the second way, so total resistance, series is different. All you have to do is add them up. And then for series, because there's only one way through, automatically all the current goes through all the resistors. So as I set these guys up, all the current, 0.089, all the current, 0.089, all the current, 0.089, and I now have all the current going to all the resistors. So current 1, 0.089 amps, current 2, 0.089 amps, and I3. All right. From there, all we have to do to find the voltages of each is to use our delta V equals I times R. So if I look at resistor 1, delta V1 equals I1 times R1. Okay, I want to find the voltage. I have the current, I have the resistance. So I take 0.089, multiply it by the 25, and when I do that, I find that the total voltage, I'm just going to kind of 2 decimals, 2.23 for delta V1, 2.23 volts. From there, moving on to resistor number 2, delta V2 equals I2 times R2. I'm solving for the voltage. I have the current, 0.089, and I have the resistance for resistor 2, it's 150. When I multiply those guys, I end up with 13.35 volts. All right, last one, resistor 3 over here. I'm just going to kind of put it down in the corner. Delta V3 equals I3 times R3. I3, 0.089. Resistance 3 is 50. When I multiply those by each other, I end up with 4.45. I have now found the current and the voltage through each of the 3 resistors. All right, so that's a recap of what we learned last week. If you flip it over to the back side or continue on, if you're in Notability, problem 3, you're going to see we have a little bit of everything in here. We have some series and we have some parallel resistors. Okay, so combining the 2. So I always use colors and I run my current through and see how many paths are going to be. Okay, so you start at the negative, you move away from the negative. One path is the pink one, and then a second path is going to be the blue one. Okay, what I have to figure out first is which resistors are parallel and which resistors are series. Okay, series means it gets all the current. All the current is both pink and blue. Okay, so I start with resistor 1. It gets only pink. That's not all the current, so that's parallel. Resistor 2 gets only blue. That's not all the current. That's a parallel resistor. And then all the current comes back together right here, and both colors, all the current, flow through resistor 3. That makes resistor 3 a series resistor, whereas resistor 1 and 2 are parallel because they only get some of the current. All right, how we solve for the total resistance. You have to do your parallel ones first because you still have to do 1 over. So this is parallel and this is parallel. So it's starting off, step 1 is always finding the total resistance. I have to do the 1 over for the 2 parallel resistors. 1 over 75 plus 1 over 25. I type that into my calculator. I get 0.053. That is not my total resistance for those 2. That's 1 divided by. So I got to do that quick flip. I got to take 1 divided by 0.053, and when I do that, I get 18.75. That is the total resistance for the 2 parallel ones. Had to do them 1 over. From there, you get to add in the series regularly. So to the 18.75, I add 50 to get a total of 68.75. All right, so when I have both types of resistors flowing, parallel, only some of the current, and series, all of the current, both colors, I have to do the parallel, still 1 over 75 plus 1 over 25. I have to get my answer, 1 divided by, get my total resistance for those 2, and then to that I just add it normally. Second step, still the same. Delta V equals I times R. I take the voltage of the battery, which is 50, set it equal to the total current times the total resistance that I just found, 68.75. And when I divide that over, I got like 0.72 repeating. I'm just going to round that to 0.73 for my total current. All right, same 2 steps. It's just slightly different how we got the total resistance. Okay, from here, I'm going to take a second. I'm going to set up my unknowns. I like to just get everything in one place. I'm going to need to know the current and the voltage for each of the resistors. You got to have a place to start. You need a domino. Okay, what you currently know, total resistance and total current. We know one of these resistors gets all the current, both colors. If you look back at it, the series resistor, the one that gets all the current, both colors, is resistor 3. If all the current is 0.73, then 0.73 has to be I3. Resistor 3 gets all the current. All the current is 0.73. I3 has to be 0.73. From there, we can, I'm just going to switch to a different color. From here, we can find the voltage. We have the current, we have the resistor. So knowing that delta V3 equals I3 times R3, we have the total current, 0.73. We have our resistance of 50. If I multiply those two together, I find that my voltage there is 36.5. 36.5. It's kind of hard to read it up there. I'm going to put it down here as well. All right. I have taken the series circuit. I have given it all the current, and from there I was able to find its voltage as well. Okay, how do you make the jump? How do we jump from a series circuit to the parallel circuits? The only way to make the jump is through the voltage. As you follow a path, the voltages have to add up to the total voltage that you start with, which in this case is 50. Okay, so I'm going to switch colors to pink. We're going to follow the pink path. As we follow the pink path goes through resistor 1, and then it continues through resistor 3. By the time my current, pink current, flows back through 50 volts that it leaves with, some of it gets used through resistor 1, some of it is used to push through resistor 3. The two voltages have to add up to the total. That's just one of the rules. Okay, so as I follow the pink path, delta V1 plus delta V3 have to add up to 50. The voltage here plus the voltage here have to add up to the total voltage. Well, the good news is I already know what voltage 3 is. It is 36.5. All I have to do is a little subtraction. So if I take 50 and I subtract the 36.5, I find that delta V1 should be 13.5. From there, I can write now, also still on the pink path, now that I have the voltage and the resistance, I can find the current there. Okay, so I'm just going to slide it up a little bit. Delta V1 equals I1 times R1. I now know the voltage here is 13.5. I want to solve for the current, and I know the resistance, moving things around, sorry. The resistance is 75. So if I take the 13.5 and I divide it by the 75, I find that the current flowing through resistor 1 is 0.18. So I1, 0.18, I1, 0.18. All right, so in any loop, the voltages have to add up to the total voltage of the battery. Okay, I'm going to switch to the blue loop. All right, so now we just have to repeat this process, but we need to do it for the blue loop. Okay, following the blue path. As I go through the blue path, I go through resistor 2. It comes back up here, goes through resistor 3, and then back to the beginning. So voltages in a loop have to add up to the total, which is 50. So the voltage through resistor 2, delta V2, plus the voltage here, delta V3, have to add up to 50. So delta V2 plus delta V3 has to add up to the total, which was 50. Once again, I already know delta V3. It is 36.5. I just once again have to subtract. You should get the same number. Delta V2 is 13.5. So delta V2, 13.5. These two are parallel to each other. Resistor-wise, they should have the same voltage. Okay, and then finally, my last step, now that I know my voltage and my resistance, delta V2 equals I2 times R2. All I have to do is plug in those numbers. 13.5 equals I2 times resistor 2, which was 25. When I take 13.5 and I divide it by the 25, I end up with 0.54 for my current. 0.54, 0.54. You can do a quick check. Your two currents, where it splits, current I1 and I2, they should add up to get you close to the total, which was 0.73. When I add that up, I get 0.72. That's really close, off by 1/100 of a decimal. So we're good to go. All right, this is our goal for this week, to make sure we know how to do the easier, the series, and the parallel, and then to be able to add in and combine the two. Thank you.